Why, it's Mr. Squirrely taking a quiet bath. Ah, so relaxing. Mr. Squirrely, have you ever wondered why you can see so many colors in your soap bubbles? Would you like to find out? Of course you would. A soap bubble is a thin film, but its thickness varies across the surface. Because light is made up of red, green, and blue light waves, different amounts of each color are reflected off the surface. Let's find out why. Light is a wave, and different color light waves have different wavelengths. When a light wave hits the surface of a translucent film, some of it is reflected off the upper surface, some is reflected off the bottom surface, and the rest passes right through. Here is a blue light wave hitting the surface of a bubble. As you can see, some of the wave is reflected off the top, some is reflected off the bottom, and some passes right through. In this spot, the thickness of the bubble corresponds to the length of the wave. So, the waves that reflect off the top and bottom of the bubble line up perfectly, sending a very strong blue signal back into the air. Now, suppose a red light wave is hitting the same part of the bubble. Because red light waves are longer, the portions that reflect off the top and bottom surfaces do not line up. They cancel each other out and do not create a very strong red reflection. However, if the bubble was thicker, then the red light waves would line up and the blue light waves would cancel each other out, making the bubble appear red. We can plot how much light is reflected for the entire color spectrum. This bubble has lots of blue, some green, and very little red, so it appears greenish-blue. Since we know how long light waves are, we can look at the color of the bubble and determine the thickness. I'll bet you never thought bath time could be so educational. See, Mr. Squirrely? Measuring thin films is good, clean fun.